Find the area bounded by the curves y equals x squared minus 2x minus 1 and y equals negative e to the negative x minus 1. Find the area bounded by the curves y equals x squared minus 4x plus 3 and y equals negative x squared plus 2x plus 3. Okay, so it looks like we got a couple parabolas, more or less. And looks like they both have plus 3, so I have a y-intercept of about plus 3. One's facing up and one's facing down. Let's find out where they intersect. So if we have x squared minus 4x plus 3, and we just set them equal to each other, we'll find out where they're equal to each other. And one of them we kind of sort of know is at 0. But there's probably another point as well. So we set the two equations equal to each other. Start simplifying things, and we get 2x squared by moving the x squared over. We have negative 2x equals 0, and then the 3's cancel. Move the negative. Ooh. Good call. Good catch. That should be a negative 6. Negative 6x. There we go. Thanks, guys. Okay. Divide both sides by x. 2x minus 6 equals 0. And then we have x equals 6 over 2, which equals 3. So they also equal at 3. So we plug 3 in. We have y equals 3 squared minus 4 times 3 plus 3, which equals 9 minus 12 plus 3. I know that's really sideways there. Way, totally uncalled for. So that's 0. So 1, 2, 3. So we have a parabola that goes up. Maybe. And then a parabola that goes down. And they intersect at 3, 0 and 0, 3. And the top parabola will be the one that's facing down. Will be y equals negative x squared plus 2. Plus 2x plus 3. And the bottom parabola, this guy right there, will be x squared minus 4x plus 3. And we'll find the area of the top integral, subtract the area of the bottom integral, and that'll give us the area bounded by the regions. So if you have time, this would be a good one to put this in your calculator just to make sure, because even though I'm fairly confident in what we did, I make mistakes. I make a lot of mistakes. And any of you guys that have watched this for any length of time, you know that's 100% true. Not as much as many mistakes as Miss Calculator's making. Come on, calculator. Oof. Okay, wait a sec. Okay. Y equals, let's start out with, yeah, we'll start out with the bottom one. So x squared minus 4x plus 3. And then we have negative x squared plus 2x plus 3. And then our window, let's see, is going to be from, I'll say negative 1 to 4. That'll just give us a little bit of buffer on both sides. And then it probably doesn't go too much higher than 3. So we'll say the y min will be negative 2. And we'll say the y max will be 5. So it comes down. Yeah, that's pretty good. Looks like the intersection point's a little bit further over here, but general idea. Yeah, okay, I'm good with this. So top graph minus bottom graph. Yes, okay. So now we get into the actual meat of the problem. So much setup. There's so much. I don't like this much setup. So this is a little bit more complicated than you'd probably get for an AP exam multiple choice, just because the amount of time required to set up the graph is a while. You have a calculator problem and you get like about 3 minutes to solve it. And maybe you could solve this problem in 3 minutes, but it would be difficult. And yeah, it'd be challenging. So this might be a little bit more challenging than you would probably get on a multiple choice. but you definitely get this concept tested. And it might be simplified slightly in one way or another. So we have 0 to 3. 0 to 3. Green. All right. I'm gonna distribute the negative sign, and I'm gonna combine the factors. Negative 2x squared plus 6x plus 0, because the 3 plus the negative 3 goes to 0, dx, integral. This is very similar to what we had before, which makes sense when we solved for the intercept point. So then we get negative 2x cubed over 3 plus 6x squared over 2, which will be negative 2/3, yes, we already know that, plus 3x squared. And this will be evaluated from 0 to 3. We know the 0 will just go to 0 because every term here has an x involved. So this would leave us with negative 2/3 times, I'm going to call this 3 squared times 3. That way it's easier to see that it cancels out. Plus 3 times 3 squared. So this will be, get my blue. So negative 2 times 9 will be negative 18. Plus 3 times 9, which is 27, which gives us 9. Is that a possible? Yes. Haha. Yes. Good for us. So 9. And you can see here that, so what happened was, looking back at the problem, we had two areas we had to graph. It took us a little while to set things up and figure out, all right, which areas are we talking about? We kind of suspected the way things went from the beginning. So if you're really in a rush, you can be like, well, this is an upwards parabola because there's an x squared. This is a downwards parabola. They probably intercept, set them equal to each other, solve for the intercept points, and then just do, well, the downward facing minus the upward facing. It's not a good way to do it because you're never quite sure that that's the way things are going to work out by just looking at it as simply as we did. But, you know, if you're pressed for time and you really need to get the problem done, yeah, it might work. And in this case, it would have. So we took the area under the curve for the top, which was something like this. Area in the curve for the second, which was something like this. Subtract the 2, and then we had the area in the middle. And this is how you do a find the area region by the region bounded by two curves. So hope this helped, and I will see you guys on the next problem. Thank you much.